Today we're talking about permutation and combinations. Permutation is every possible order of objects. What we're going to do is we're going to talk about the possibilities. How many times will something occur, or how many times could it occur, with like order of like who's sitting where, or just different kinds of order. And we're going to talk about that. Okay? Permutation, it's every possible order of object. All right? You need to write this down. So it says a travel agency is planning a vacation package in which travelers will visit 5 cities around Europe. How many ways can the agency arrange the 5 cities along the tour? So let's think about it. There's 5 cities to pick from, right? So the first stop, I have 5 cities to pick from. How many cities do I have to pick from the next stop? 5 or 4? 4. Why would you go back to the first city? Right? So I times 5 with 4. What about the third stop? How many do I have to pick from? 3. What about the next stop? 2. And what about the last stop? 1. Okay, so if we're trying to figure out how many ways they can arrange the 5 cities, I take 5 times 4 times 3 times 2 times 1 gives me 120. There's 120 different ways they can arrange 5 cities. All right, now here's the formula. What we just did is what we call a factorial, which means we took the number we started out with, that was 5, and we just did 5 times 4 times 3, so on until we get to 1. That's a factorial, when you're just timesing a number by itself, but you're subtracting 1 from it each time. Right? So the first one was 5, this was 4, and then you subtracted 2, so that's how we had 3, and so on. That's factorial. For permutations, to figure out permutations, we use a factorial. Just a number with that exclamation point means you just times it by itself and then subtract 1 each time.
So basically we count it.
So permutation formula is this right here. Okay, P is the N over R. N is the number of objects. R is how many objects are taken. Because sometimes, like the city one, it had 5 cities to pick from, and you used all 5. You had 5 stops. But not always do you use every stop. Let's say you only had 3 of those cities to pick from. So what you do is you use this formula. So you take the number of objects factorial over the number of objects minus how many you take, which if you only had 3 stops, you do 5 minus 2 factorial, or 5 minus 3 factorial. So this is permutation formula. So write this down. This is the librarian is placing 6 out of 10 magazines on a shelf. How many ways can she arrange the magazines in the case? See, this is giving you 10 different magazines to pick from, but she's only using 6. So this is when you'd use permutation formula, which is this. P of NR, alright, is equal to N factorial over N minus R factorial. So what's my N? How many objects, right, do we have? 10, right? So I do 10 factorial over, and then how many objects do I get to take? 6. So I do 10 minus 6 factorial. Which was 10 minus 6? 4. So I do 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Over 4 factorial, which is 4, 3, 2, 1. Well, we know, in what we did last week, that you can cancel these out. So what you do is you take 10 times 9 times 8 times 7 times 6 times 5, and you get this number right here. For just 6 out of those 10 magazines, you can arrange them in 151,000 ways. All right, now we're going to talk about combination. We did permutation, and that's where order mattered. Okay, for going to those cities, wouldn't that order matter? Yep. Right, if you're trying to go the least amount of distance between each city, the order would matter. For combination, the order doesn't matter. Meaning, if you have the think of example. Okay, if you have the same selection of the cities, let's say you pick 3 out of the 5, right? You don't count those times when it occurs, even if it's a different order. Like let's say Pawnee to Ralston to Stillwater. You pick those. Well, what if your order was Stillwater to Ralston to Pawnee? It's the same, isn't it? Okay, it's just a different order, so we don't count those. So with combinations, the number is going to be smaller. With permutation, it's a large number. Like on the magazines, there was 151,000 different ways. Combinations, it's going to be a slightly smaller number. What we do is we do combination. N is still the number of objects, and R is the number of objects taken. So we do N factorial, the number of objects, so the 5 cities. Then we do the number of objects, so if we were only using 3 of those cities, we subtract that from R, and we do that factorial. And then we also do R factorial. So write this down. Alright, so let's do the combination of this. Okay, Mark has been asked to display 5 different style shirts from a wall that has 8 shirts on it. Alright. So how many ways can Mark choose the shirts? So what we do is we use the combination formula, which is N factorial over N minus R factorial, R factorial. So how many total objects can he use? How many shirts can he use? 8, right? 8 different shirts to pick from. So we do 8 factorial on top. On bottom, we do 8 minus 5 factorial, because he can only use 5. And then to get rid of the identical objects, right, ones that might occur twice, we do R factorial. So you do 8 factorial over N minus R factorial times R factorial. So we work out 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1, over. 8 minus 5 would be 3, so we do 3 factorial, 3, 2, 1, and then we do 5 factorial, which is 5, 4, 3, 2, 1. 5 through 1 would cancel out with 5 through 1, and then you got 3, 2, and 1. So when you take 8 times 7 times 6, you get 336 over 6, because 3 times 2 times 1 is 6. You divide that, and there are 56 ways for Mark to arrange the shirts. Alright, so the problem, it says that a group of 4 students is selecting corsages and different flowers to wear to spring dance. They can choose from 18 different flowers, which consist of 4 roses, 6 carnations, 8 tulips. How many ways can 4 flowers be chosen? So you have 18 different flowers that can be chosen. You use 4, okay? So what we do is we do 18 factorial over 18 minus 4 factorial, and then 4 factorial, right? So we write out 18, 17, 16, 15. Now I'm not going to do 14 and on, because I know that this right here is going to be 14 factorial, right? Which would cancel out. This is going to be 4, 3, 2, and 1. So I've gotten rid of 14, everything down because of this. So I would cancel those 2 out. So I would do 18 times 17 times 16 and 15. Divide by 4, 3, 2, and 1. When I do that, when I work that out, I get this. 3,060 different options. Here's your homework assignment.